Hello, and welcome to this presentation on PARSEC, a new platform abstraction for security. Okay. I'm Ionut Mihalcea, and with my colleague Hugues de Valon, we'll be holding this presentation. We are both software engineers at ARM, based in Cambridge. We've both been working on PARSEC since its inception, and we're available to contact on the emails shown on the screen right now, or on the PARSEC channel in the Docker community hub. Okay. So first off, PARSEC appeared as a collaborative project, open source project, seeded by ARM and Docker, and then by Mirantis when they acquired the enterprise version of Docker. It was envisaged as a community-driven project, and as such, it was donated to the Cloud Native Foundation as a Soundpath project recently. So first off, what is the project and what is the problem that PARSEC is trying to solve? So the problem is tightly linked with the emergence of edge computing. So edge computing is the concept of deploying workloads and processing data close to where the data is generated. So instead of processing the data in cloud somewhere in the data center, the data is processed on an edge station somewhere close to where the IoT nodes or whatever the source of the data is. It's also linked to the massive momentum that has been built up around cloud native development, provisioning, and runtime management practices, and trying to essentially leverage the skills that developers have built up in using cloud environments, and trying to leverage those skills into the new edge compute framework. The problem is that edge computing presents its own different challenges, and PARSEC in particular tries to solve two of those issues. The first one is the fact that for edge computing is inherently more insecure than just processing data in a data center. So developers have to actually pay a lot more attention to how they handle their sensitive data, in particular their cryptographic material, for example. So this has to be preferably handled with some sort of hardware backing. The second issue is that of fragmentation. So edge computing stations usually will have will be backed by different kind of hardware. So for example, one platform might have a discrete EPM, another one might be using some sort of trusted execution environment and having a trusted app that does cryptographic operations there. So essentially what PARSEC is doing, and PARSEC sits in between the workloads and the hardware, and is essentially, in one sentence, you can describe it as a hardware abstraction layer for hardware security modules. So you can deploy any workload written in any programming language using any container runtime on any architecture or any hardware using the same one API. So on a conceptual level, this API is very, very important. It's a very consequential choice. We could have developed our own API, but instead we chose to go through the platform security architecture framework, which is a framework of resources aimed at helping developers create more secure systems or platforms. So this PSA framework contains the PSA crypto API, which was developed as a modern toolbox geared for any workload, any cryptographic workload. The problem being that this crypto API is a C specification, a C API, whereas we want to present it as a part of the environment for applications written in any language. So the next layer, the next conceptual layer is a service. So we wrap the API in a service and offer it as such as essentially a piece of furniture in the workload environment. Obviously, because we want other processes to be able to communicate with the service, we need some sort of inter-process communication. So the next conceptual layer is an IPC wire protocol, a generic IPC wire protocol that isn't tied down to any particular technology of transport or any encoding standards. So you could use either, for example, Unix domain sockets or TCP. We'll be talking more about that in the next slides. And then the next conceptual layer is an ecosystem and client libraries, where libraries for different languages are exposed, allowing developers to use the API in a way that's idiomatic for that language. And to use it at whatever level of abstraction they require. So whether they want to use a very low-level API where a lot of options and functionality is available, or whether they just don't care about the particulars and they just want to, for example, encrypt some data. So overall, this conceptual view bridges creates a bridge between the engineers and the hardware that they use in an abstract way. So now for the service architecture, I'll pass on to my colleague.
Yeah, thanks, Ionut. So yeah, going from the conceptual view of PARSEC to what it really is, we can see the global architecture on this diagram. So you can think of all of this being contained in an edge node, for example, on a Linux platform. So at the center of it, the PARSEC service, which is a service written in the Rust programming language. Rust was chosen over other programming language for its safety guarantees, and it would fit nicely this system software, which needs to have strong safety and security guarantees. The PARSEC service, on one side, on the provider side, communicates with the different security module that PARSEC supports. So, for example, we have there the TPM using the TSS API for communication. We have HSM using PKCS11, and we can have a trusted app inside a trusted execution environment, for example. On the other side, so on the front end of PARSEC, there is the listener, which is the component responsible for getting the client request and sending back the responses. And in between the two, there is the whole PARSEC logic, the one that takes the request for multiple clients, brokers, the request between them, perform access control between every client, and really do the full PARSEC logic. A big architecture view of PARSEC is that any of those big Lego brick, let's say it this way, can be pluggable and replaced by another implementation. So an example of this is the listener that we currently have in PARSEC is using Unix domain socket as an inter-process communication with the client. But this could easily be replaced with another implementation, which, for example, works on Windows. That is the case for the listener, and that is the case for many other parts of the PARSEC service. On the left side, we have the application. We have the application that is deployed on an edge node in a cloud native delivery and orchestration way. This application contains the PARSEC client library written in the programming language of choice by the application, so ideally the same programming language than the application, and which communicates to PARSEC using the wire protocol format based on the PARSEC crypto API. This format also includes the definition of the specific operations that the client library wants to execute on PARSEC. And these operations can be also described in different language agnostic format. The current one that is used by PARSEC is protobuf. So on all the left side of this diagram, there is truly the platform agnostic parts, the parts that do not really need to care about the specific implementation on how the access to the security hardware is done. So still on the left side on previous diagram, there were our client libraries, and PARSEC has a strong view on the client libraries ergonomics, which is done on multiple layers. At the lowest level layer of our client library, we have the core of the library, the part that directly maps to every single operation that we support in the PARSEC crypto API, and that allow users to use them with any possible parameters that they want. So it's really the layer which is complex because one needs to understand all the specific parameters that the hardware can do and that they want for the operation with their consequences. So it's a layer providing a sophisticated use case with a granular control. But we did not want to only stop there, and we also wanted to provide a higher level of abstraction layer, something that is easier to use for developers, and that is done with two principal things. The first one is the thanks to capability profiling and smart defaulting. A user of that layer could simply request high-level crypto operation to be done, for example, signing a buffer with a private key, but without having to specify all the single parameters that go with it. For example, what signing algorithm to use or what hashing algorithm to use. This would be done by the library itself with a capability profiling of the PARSEC service it communicates to, and having smart default in there as well. And the second part of this is an added abstraction. Depending on the programming language that is used in the library, that the library is coded in, there would be different kind of abstraction, different kind of idioms. And we really wanted each library, as I said, not only being a mapping of the PARSEC crypto API, but really use all the features of the programming language. So having in the Rust library the Rust idioms, and for example, in the Go library the Go idioms, and the same way for all of our libraries. So one part, big important part of PARSEC was its API, its abstraction over the PARSEC crypto API. But the other important part as well is the multi-tenancy view. PARSEC allows multiple tenants, multiple applications to access it at the same time. For that to be done, PARSEC needs each application to have a unique and persistent application name, application identity. The way that each application gets its own identity is needed by PARSEC, but is not included in PARSEC code base. PARSEC does not prescribe any way that the application receives their identity. And this is so because depending on the deployment of PARSEC, different options could be possible for that. So the identity provider is the component that gives to the application the identity, the external component that gives the application that identity. And it's those identity that are sent to PARSEC whenever the application wants to make a request. That way, PARSEC can perform the brokering, the access control, and the key store partitioning. The goal for that is that each application trust PARSEC so that the other application cannot access their keys. The keys are partitioned, and one application do not want the other one to be able to access their private key, for example. For that to be possible, there needs to be a relation of trust between PARSEC and the identity provider, so that PARSEC can trust the identity that the application are giving it. That trust relationship can be, for example, done with a certificate sharing between PARSEC and the identity provider, and it will depend on how the identity provider is implemented. So that's the way PARSEC allows the multi-tenancy, and that's the way PARSEC allows multiple applications to use it securely. So now we've seen the API part of PARSEC, we've seen the multi-tenancy part. If we want to summarize the global value proposition of PARSEC, we can see it with the following points. So we have the abstraction. PARSEC offers a common API that is truly agnostic and based on modern cryptographic principle. Mediation. PARSEC offers security as a microservice, brokering access to the hardware, and providing isolated key stores in a multi-tenant environment. Ergonomics. The PARSEC project offers client libraries ecosystem that brings the API to the fingertips of a developer in any programming language, easy to consume, and hard to get wrong. And openness. PARSEC is an open source project inviting contribution to enhance the ecosystem, both within the service and among its client libraries. And I would like to reiterate on that last point, which is particularly important for us today. Even though PARSEC was started with a collaboration with ARM and Docker, and that's mainly ARM and Docker employees started. We really try our best to be a welcoming project, a transparent project, and really welcome any kind of contribution that could enhance the ecosystem. And on that topic, we can take a look at our contribution landscape today. So this table here, with different categories of the PARSEC project, describes where we are today, with what's available, what's partial, and what's to do. So let's have a quick look. If we see the client libraries, we can see that we have a working Rust library, we have a C client library as well that is using Embed Crypto, and we have the skeleton available for a Go client library. Python, Java, and other programming language library are excellent library that could be used with PARSEC, but are not done today. For operations, so what is possible to do with PARSEC, the main thing is asymmetric signing, so the ability of signing a buffer with a private key and verifying it with a public one, and that is supported on all of our backends, so TPM 2.0, PKCS 11 backends for HSM, and our software backend, PSA Crypto. That is not really to be used in all use cases for secure development, because it's everything is stored in software, but it's very useful for developers to try everything in software. In the future, we would like to add more operation and add all operation that PSA Crypto supports. So our backends, as I said, those are the three that we have now, and as well we would like in the future to add more. The backends really take part of what I described as a pluggable architecture. It should be easy to add more backend without changing much in PARSEC. And in terms of the environment, we have current support for single tenancy. Multi-tenancy, we have partial support. As I said, we don't have currently an implementation of an identity provider, but there is work going, for example, with the SpyFi project to define one. And there are also ideas of defining one in Linux system, for example, using a user ID as a way to give an identity to application. Multi-tenancy now work in Linux using group permissions. multiple PARSEC clients that trust each other can all access securely the PARSEC service without everybody on the system accessing it. So that's the way we currently allow multi-tenancy. We currently also only support Linux, but Windows support would be really, really nice to have. The way PARSEC is a prescribed installation now is a manual compilation and installation, installing it as a systemd service on the system. But it would be really, really nice to also have it available in package managers, and for example, Linux distribution package manager, to make it way easier for administrators to install PARSEC on their machines. And that is for the PARSEC service itself. We also, I forgot that one. We also would like to add more IPC mechanisms, and that would be important for Windows support, for example, because the current one is a Unix domain socket, but obviously that would not work on Windows. If you look at that, at that contribution landscape, all of these parts, we would be more than happy to discuss with interested people, people that like the PARSEC project, that like the PARSEC ideas, but for example have their application in Python, and so they wouldn't be able to access PARSEC. We would be really happy for them to contact us, to discuss with us, and to see how we could add more things to PARSEC. It should really be a community project. This is not only an ARM project, it's not a Docker project, but we really want to make it a welcoming and a nice project for everybody to help. On that note, if you would like to contact us and to learn more about the PARSEC project, here is a few links. So all of our related PARSEC projects are under the GitHub Parallax second organization, which you can find a link there. So there is there, for example, the PARSEC project itself, but also the client, the Go, the C clients, and some crates that we created along the way, some Rust crate that we created along the way. You have a link to the book, which contains all of PARSEC documentation. And if you would like, if you found some topics that piqued your interest and would like to talk more about it or to discuss with us for some specification, really don't hesitate to talk to us on the PARSEC channel on the Docker community Slack. All of us are there, and we'll be really happy to discuss with you. And if you have some specific topics that you would like to discuss in more depth, we also hold a bi-weekly community call. You can find information how to join on the link below, and also a link to the agenda, where you can, if you have some specific topics that you like to discuss, you can write on the agenda the link, and we will discuss it at the next meeting. Really, we're happy to discuss about anything PARSEC related. And yeah, I think Ionut and I made a nice overview of PARSEC. Don't hesitate to talk with us if you are interested, and thank you for listening.
Thank you.